$5 copay, one had a $20 copay, and one had more than a $20 copay. Table 1 gives you the number of people in each of these groups, then also describes how comparable they are. So you'll notice that this is a study that's made up of mostly 40 to 65-year-old people, which makes a lot of sense because what this study is looking at is antihypertensive medication. You would expect relatively few people under 40 to be diagnosed with hypertension and therefore being on antihypertensive medication. But you see roughly half of your people in this study are between the ages of 40 and 64, and half of them are above 65 years of old. And you can see that roughly half of them are females and half of them are men. So this gives you an idea first of the type of person who's in your study. That's going to help you for generalizing the results to other data sets. So for example, you see you have a lot of people in this study who are of the Japanese ethnicity group. You have very relatively few people from the Chinese ethnicity group. But that would help you decide on maybe generalizing these results to certain ethnic groups. But more importantly, this table 1 is also showing you how comparable these two groups are. So for example, in the lower copayment groups, 48% of individuals are over 65 versus 45 in another group versus 46 in another group. So it gives you an idea of the potential for confounding factors that might be imbalanced in these various groups that they're comparing, and also might be indications of developing the outcome of interest, namely compliance. But notice table 1 in this manuscript doesn't have a fourth column, which tells you whether the age distributions are statistically different in these three groups, or whether the sex distributions are statistically different, or the ethnicity classes are in this particular table. If you look at table 2, the same paragraph, these are crude associations. These are associations between patient characteristics and the outcome compliance. And what we have here are the percent of people who comply. Notice that the percentage of compliance is increasing with age, slightly higher in males than in females, slightly higher for people who have low morbidity, highest in the people who have a Medicare cost contract coverage, and highest in the people who have Japanese ethnicity. But all these are crude associations. And notice there are no p-values added here, although there's a footnote saying all groups differ where statistically significant. Whether this p-value is appropriate or not is whether you feel that these differences are only reflecting the effect of age or sex or morbidity, whether they could be confounded by other factors. And if they are, you'd be better off doing an adjusted analysis. And that's what was formally done in the next table, table 3. This is a logistic regression model results, something we'll be talking about next week or the week afterwards. These are adjusted odds ratios, meaning all the numbers in the adjusted odds ratio column here are measuring the effect of one factor on your outcome, controlling for everything else that's in this model. So if we look at the odds ratio corresponding to the oldest age group, it's comparing the oldest age group to the youngest age group. The size of the odds ratio measures the strength of the association, the effect of older age on your outcome. And the 95% confidence interval in the next column gives you an idea of the precision of that estimate by giving you a range of values that are supported by these data. So even though the odds ratio itself looks very large here, and I cannot see these numbers so well. Let's look down to, this looks like it's going from 0.47 to, that number, is that 9.47? I don't have the manuscript. Yes, I do. Hold on a second. Let me multitask for a second. Oh, the confidence interval is 0.048. It's going from 0.047 to 0.049. Let's look at another one. That's for the, so this is showing that there is roughly a 50% decrease in the odds of compliance. You compare people who are paying the most for copayment compared to the people who are paying $5. But that group is less likely to comply if you have to pay a larger copayment. And that odds ratio of 0.48 is fairly precise because the confidence interval says it could be as low as 0.47 or as high as 0.49. That's a very tight confidence interval. And in part, that's because we have a very large study here. If you go back to table 1, notice that there were 60,000 people, one of the groups, paying more than $20 for their copayment account versus almost 60,000 people paying $5. And that's going to affect the size of that confidence interval. That's why the confidence interval is very narrow, going from 0.47 up to 0.49. Let me give you one other example before we talk about statistics. This was that large randomized trial that was distributed looking at 3 different methods for preventing diabetes among high-risk people. Remember, one of the intervention methods was a lifestyle intervention, and the other one was pharmaceuticals with a drug. But what did they show in their table 1? Table 1 is comparing the people in the 3 groups, the people who received a placebo versus people who received a drug, metformin, versus people who received a lifestyle intervention, roughly 1,000 people in each group. And it gives you an idea of what the sex distribution, the race, ethnicity distribution is for these people, the age distribution are. You get a feeling for what type of person was in this study. But we also get a feeling for how comparable the groups were. Remember, this was a large randomized controlled trial. So notice that 3 groups are very similar with respect to the distribution of men in the 3 groups, 31% versus 60% versus 32%. The average age is 50 versus 50 versus 50, very similar. This is what you'd expect in a large randomized trial. When you flip a coin, a 3-sided coin, the coin doesn't know your age. Age doesn't matter. You'd expect just as many old people to be put into one group as any of the other 2 groups. And notice there's no p-value put here. We'll be talking about p-values today and tests of significance, and I said about half the tables you will see. And in my view, I don't really see a strong reason for putting p-values in this particular table. Because as we will talk about as we move on and talk about statistics, is the p-value is testing a hypothesis. For example, we'll be testing the hypothesis whether the sex of the individual was related to which group he was assigned to. But randomization tells me that that hypothesis is true. A 3-sided coin doesn't take my sex into account when it assigns me to the placebo group or the metformin group. It's true. The chances of being assigned to a group is not related to your sex. And therefore, you wonder why even do the test of significance. But we'll get back to the test of significance and maybe talk a little bit more about their relevance as we for tables 1 like this. This is their table 2, showing the incidence of diabetes in the 3 groups, the placebo group, the metformin group, the lifestyle group. The next 3 columns gives you essentially rate ratios, the rate of developing diabetes in one group versus another, comparing lifestyle to placebo or metformin to placebo or lifestyle to metformin. But notice here they've added confidence intervals around that. And this is appropriate because in a randomized study like this, we would not expect confounding factors. We would expect these crude associations to be only reflecting the true effect of lifestyle intervention, say, versus placebo, or metformin versus placebo, or lifestyle versus metformin. Because from the previous table, we saw all those other potential risk factors for developing diabetes were balanced. This should not be confounding in these results, and therefore making statements of statistical inference, either putting p-values in, as I mentioned in the bottom of this slide, or by adding confidence intervals, which are put next to these rate ratios, seems fully appropriate. Now, this table did other analysis. This study did other analyses. They looked at other outcomes. One of them were adverse events. Even if it is lowering a person's risk of developing diabetes, if it's causing more symptoms and pain, you'd want to know that because that might come into the decision of whether this drug should be assigned to an individual or not. And that's what's showing here, various adverse events, side effects in these 3 different groups, mainly looking to see if the metformin group has more side effects than, say, the placebo or the lifestyle